Welcome to Study Loop.
Problem 45 gives two examples of a chemist decomposing either carbon monoxide or hydrogen peroxide and gives the results of those decomposition reactions and then asks you to determine if there are any patterns in these results and what they might tell you. So the first couple of reactions, the decomposition reactions, are these here, where the chemist decomposes carbon monoxide. So there are three samples listed here in the table. And part A of this problem asks you to describe any patterns you notice in these results. So one thing that you can see here is that the resulting masses of carbon and oxygen scale together. So here there's a 6:8 ratio, a 12:16 ratio, and an 18:24 ratio. What this boils down to is a 3:4 ratio in carbon to oxygen that's constant no matter what the sample, no matter what the starting size of the sample decomposed. So this is in line with the law of definite proportions. After this, the chemist decomposes hydrogen peroxide, and again there are three samples listed here. And portion B of this question asks you again to describe any similarity you notice between these results and those for carbon monoxide in part A in that previous table. So again, the ratios of masses of hydrogen and oxygen scale together. Importantly, in a 1:16 ratio that's constant between hydrogen and oxygen here. So this is the same in both of these decomposition reactions, where no matter what sample you have of either carbon monoxide or hydrogen peroxide, the masses of atoms or elements making up these compounds exist in constant ratios. So part C asks if you can formulate a law from these observations, and like I said in part A, this idea fits really well with the law of definite proportions, which states that any sample of a given compound, no matter its source, has the same proportions of constituent elements. So finally, part D asks if you can formulate some sort of hypothesis that might explain this law in C. And one possible answer for this, and there are many, is that if a given compound is decomposed, whether carbon monoxide or hydrogen peroxide in these cases, then the masses of the constituent elements will be equivalent to the starting mass of the compound and in the appropriate expected proportions.